Hello Hodghill. So today we're going to calculate volumes of cubes and cuboids. The prerequisite of something you may have seen before would be surface area, cuboids and cylinders. So today the new keyword that we're going to be going through is volume. That's this one over here. Some of you may be wondering where it's applicable in real life. It's applicable in construction, for example when they want to decide how much volume of concrete they need for the surface in a house, and how much volume of water they need to fill a cup, and I'll be going through a little bit of that in the next slide. So first things first, what is volume? So volume is an amount of substance that can fill an object. An amount of substance that can fill an object. In this case, on the right hand side, you should see that we have a cup or a glass, and the substance we're trying to fit into is water. How much water we can fit into this glass? Okay, so we now have a cuboid on the board with many little smaller cubes to fit into this cuboid. We want to calculate the volume of this cuboid. How many of these smaller cubes fit into the larger cuboid? So first things first, I'm going to calculate the area over here. How many of the smaller cubes fit into this area here? We have 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we have 9 that fit into that one area there. Next we have another section over here which also has 9, and then we also have another area here which also fits 9 of the smaller cubes, and finally we have this area over here which also fits 9. So I'm going to calculate on the left hand side the total. We have 9 cubes for the first section, we have 9 cubes for the second section, we have 9 cubes for the third section, and we have 9 cubes for the last section. So in total our volume, we have 36 cubes. Our volume is 36. In this case we're calculating volume to be how many cubes fit into the larger cuboid, but in the next couple of slides we'll be going through using centimeters. Okay, so we're going to use something very similar to the last slide that we used, and I'm going to go through a quick example on how to calculate the volume for the cuboid on the left hand side. So let's count how many of these smaller cubes fit into the larger cube. We have 1, 2, 3, 4. In this section here we have 4 cubes. Now we also have another section here which also has 4 cubes, and then finally we have a section here that also has 4 cubes. So we have 4 cubes, we have another 4 cubes on the second section, that's this one over here, and then lastly we have another 4 cubes. So in total we have 12 cubes. So the volume is 12 cubes. What I'd like you to do now is to pause the video and have a go at calculating the volume, how many of the smaller cubes fit into the larger cubes on this side here. So if you can pause the video and resume it once you've done. Okay, so I'm going to give you the answer to this now. I'm going to quickly go through it. We have one area here where we have 1, 2, 3, 4, 5, 6, 7 and 8. Now how many of those sections or areas do we have? We have another one here, another one there, another one there, and finally we have one here. So if we add these all up, we should have 40 cubes. Okay, like I said before in the previous slides, we were calculating how many of the smaller cubes fit into the larger cube to calculate the volume. Because if we repeat what a volume is, it's the amount of substance that fit into a object. So in the last one is how many of the smaller cubes fit into the cuboid. But now we've just been given some information here: 4 centimeters, 10 centimeters, and 2 centimeters. We're not calculating how many cubes. We're going to calculate the volume of this cuboid. So the volume of a cuboid is given by the formula volume equals to length times width times height. So I'm just going to show you over here which ones are the lengths, which ones are the widths, and which ones are the height. So the length of this cuboid is this one here, how long it is, and the width is how wide, which is this one here. And finally, the height is how tall it is, which is this one here, which is 2 centimeters. So let's input or substitute these values into our formula. Volume is equals to length. The length is 10 times the width is 4, times by the height, and the height is how tall it is, which is 2. So the volume is equals to 10 times 4 times 2, which is 80. Don't forget your units, centimeters cubed. When we worked out surface area, it was squared because it's two-dimensional. But now we're calculating volume, which is 3-dimensional, so it is cubed. And some of you may be wondering how we got the cube. It's because a centimeter times by a centimeter equals centimeters squared. But for volume, when we're doing centimeter times centimeter times centimeter, it is centimeters cubed. So that's the reason why we use cubed. Okay, I would like you to now pause the video and have a go at calculating the volume of this cuboid. Once you're finished, resume and I'll give you the answer. Okay, so the volume of this cuboid is 48 centimeters cubed. 6 times 2 times 4. So that's length times width times height. Okay, we've now come on to the final task. What I would like you to do is to now pause the video once we have finished talking and have a go at these 3 different sections of questions. I would like you to all start on the red. One thing you do need to remember is that the sides on a cube or a square are all the same. So one hint I'm going to give you here is 3 centimeters. The height is 3 centimeters. So that's one piece of information you'll need to know for a cube. So moving on to the rest of them, there are cuboids, and you may use a calculator to calculate this for the decimal ones, for the ones in the green section here. I would like to see all your working on your final answers, and please make sure you upload those to class charts. If you have any difficulties or any questions, please contact a member of staff on class charts. Good luck.